Hi, in this video, we want to take a look at preference modeling, specifically log linear models. All right, so we've got the situation where someone is either they're giving like a ratings from like strongly agree to a strongly disagree, or maybe we're doing paired comparisons of I prefer option A over option B, I prefer option A over option C, I prefer option B over option C. That situation for paired comparisons. Or someone is going through and they're ranking different items. Okay, so all these are definitely types of data that we have that we could roll up our sleeves and dig into. Now, the log linear models, the trick with these is that what it does is it reshapes the data in a format so that it logistic regression-ish. You can think of it as logistic regression. It's not quite that, but something similar to logistic regression can be executed on the reshaped data. Now, fortunately for us, that reshaping phase is taken care of as long as we put in the right format of the data. As long as everything is coded in a way that the machine recognizes the ratings or the pair comparisons or the rankings. Okay, so this is the main package for this in R is prefmod. And for this type of modeling, the main functions that we're going to be looking at is the pat-L fit for ratings, like Likert scales, and then pat-PC fit for paired comparisons, and then pat-R fits for rankings or partial rankings. So a ranking in this situation, a full ranking is where the subject had to rank everything like 1 to 5, let's say, or 1 to 10, where there's 10 items. Partial rankings is where they don't have to rank everything. And we're treating the situation where we have ties as being either way. That's not in consideration on this one. But of course, the data everything will run better for us if we have a proper ranking system. Now, something that's very important about this package is that we have our data in the right format. If it's in the format that the prefmod package can work with, that recognizes, then boom, everything is easy peasy lemon squeezy. If it's not in the right format, we are dead fish in the water. So data prep is going to be very important here, but also it's going to be very nuanced. We have to code things exactly the way it wants it. If we don't code it the right way, it's not going to work out. So we have to have our column names straight, we have to have our entries straight, and we have to make sure our covariates are in the right format. All these things have to be in the right manner on our data frames, or we will not get the results we want. All right, so first let's look at the pattern models for ratings. Okay, so here we're going to do some ratings. All right, so for this situation, this is similar to Likert scales. And so we have 1 is like it very much, 2 is like it, 3 is mixed feelings, 4 is dislike, 5 is dislike it very much. All right, so one thing you'll notice about this is we're going from 1 to 5 on this and the actual data, and I have to separately interpret what's going on. And so so in this situation, we're coding everything 1 through 5, but the subject, when they're taking the actual survey, they see like it very much, like it, have mixed feelings, so on. And this particular data set is with regard to music, and they say how they feel about each individual type of music. So the big B column is big band music, while the COUN column is country western music. GOSP is for gospel music, and so on. Now, later on to the right-hand side of the data frame, we also have 3 covariates of age, education, and sex. And you'll notice that sex is coded as 1 or 2, and because this really wants you to be entering integer values. The prefmod package wants integers. All right, so let's go ahead and load the data. So the data that we're going to be using is from the prefmod package. And here we can see that we have their personal ratings for each of these music types. So now let's go ahead and build our model. So for this, we're going to use the pat-L dot fit packet function, pat_l dot fit function. All right, so remember this is a Likert scale, and I'm using the prefmod package. And so, but we're, just to make this a little bit easier for us as we work through this, we're only going to look at a few different ones. So we're only going to look at 5 different music genres. We're going to look at mood, reggae, rap, hymnal, and not country. I have to look. What was CONR? Contemporary rock. So, and then this one's contemporary rock. And we're going to involve one covariate of sex. Now, how many items are there? All right, so this is referring to the number of ways that it can be, rated from 1 to 5. And then this specifies, depending on that we want it to model with using a covariate involved. All right, so let's go ahead and look at the output after we fit it. And here we get our deviance and our log likelihood. And here, here's one term. All right, so something that this is saying is that overall, it can eliminate the sex covariate. Okay, so as a whole, it looks like there's not a whole lot of difference between different genders. Now, if we look at individual ones, we'll see a difference when I start getting nuance, but in terms of improving the model globally, sex is not, not an important covariate. And so here we can go through and we see the difference on this. Now, something that's interesting about this is that it went through and it includes a term for sex squared, and it's with an interaction term. All right, so here we can see that when statistically significant, we can see that sex is going to be involved in here. So we know that it's really a categorical variable, even though it's coded as an integer. So we can see that really sex has the biggest role in terms for hymnal music. That is interesting. But we see that it's not, the interaction term is not statistically significant for the others. Now the U is for undecided. Undecided means that if it's a positive value, they are prone to, actually let me read it because I wrote it down here. All right, so the undecided parameter is useful for the tied cases. So it measures how much subjects assign the same rating to multiple items. Positive means they're prone to giving multiple items the same rating. Negative means they're prone to giving different. So when I see positive, we're more likely to see like the same value being given to multiple. So their positive means they're more likely to be undecided. And negative means they're less likely to be undecided. And 0 means it's like 50-50. Now, something about the mathematics of fitting this model is that since I'm using that log linear model structure, I have to do things that sets it up in like a linear algebra aspect, and we need a reference level for this to work out. Remember that when I'm talking about a rash model, I always have a reference level subject when I talk about proficiency overall, and I have a reference level question when I look at individual items. And so that the mathematics that makes that a requirement in a race model is coming to bear here also. Now, the lambda value is the raw measurement of preference, and this is always in reference to the reference level. The reference level always has 0. All right, so if it always has 0, you know it has 0 standard error because it's a constant value. Okay, so when you look at that, you always have to be mindful that one of your values is not actually like being truly measured. It's a reference level for everything else to be compared off of. Now, if I take the worth score, that is a transformation of that lambda. All right, so now I've got my model. I want to get the worth and the lambda out. So remember, worth is a transformed version of lambda. And how it transforms it, transforms it by controlling the sum of the values. And if I go ahead and plot this, all right, so we can see that, rap pretty similar across genders, reggae very similar, contemporary rock. Mood is a little bit different, and hymnal has a difference. So mood and hymnal has a difference going on. So if I look here, 0.3, and hymnal is, definitely statistically significant. So I'm surprised to see mood to have, such a large p-value, but maybe I'm wrong in my visual interpretation of the picture. All right, so now let's look at the lambda value. So remember, this is always in reference to the 0 value. So here we can see that the contemporary rock is the reference level because it's at 0 for both of these. Then everything else is based off of that. How far off from the contemporary rock results are the others? And we can see that mood isn't that far off from contemporary rock. Second closest is reggae, and then rap and hymnal are pretty far from the reference level. All right, so that was when I'm doing the situation where I rank each item or rate them from 1 to 5. Okay, now I want to talk about the decision where I have two options. I'd say I like A over B, and then on another trial, I say I like C over A, and then on another one, I might say I like B over A. And so all these paired comparisons. Okay, so one thing about doing this in this package, I need to have a standardized coding for the pref mod package to recognize what I'm doing. 0 means the first option was chosen. 1 means no decision was made, so I'm undecided. If I have a lot of 1s, I'm going to have a large U value. And then 2 is the second option was chosen. Okay, so in the data set, we've got 5 different emotions, and we're going to code them as 1, 2, 3, 4, or 5. Remember that the pref mod package wants integers, so specifically positive integers or zeros in this type of standard coding. And so remember, we have our standard coding, and now when we have 1 and 2, this column is when you're studying math, do you feel enjoyment or pride? Which one do you feel? You only have 2 options. Which one do you feel? 1, 3 is enjoyment or anger. So enjoyment is always with 1, as we have coded up here. 2, 3 is pride or anger, and so on. So we get all the combinations possible. It's what, probably 10? Is that right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, combinatorially 5 choose 2. And then we have a covariate of sex, once again coded with integers. And so now we get the actual column values. So remember, 0 means the first number was picked, the first emotion was picked. 2 means the second emotion was picked. 1 is undecided. So here, subject 6 was undecided on that very first comparison. All right, so now let's go ahead and build our comparison model. Once again, we are going to have a reference level, and we're going to have an undecided parameter. Remember, 0 for the undecided means that it's 50-50, whether they are prone to not come to a conclusion. Positive means that they are prone to being undecided. 0 means, less than 0 means that they are prone to not being undecided. So they make distinctions between everything. And we're going to use the pat_pc_fit function in the pref mod package. So I've got my data set coded the way I want it. Number of items is 5. All right, so because we have 5 different emotions that we're comparing. I have my covariate included in there. And here are the object names. So remember, enjoyment was first, pride was second, anger was third, anxiety fourth, and boredom fifth. So let's take a look at our model. And so here we can see where we have statistical significance, where we don't for the estimated values. So remember, these are always going to be in reference to the reference level. So we have enjoyment, pride, anger, anxiety, and boredom. Here, boredom is our reference level. So you notice that boredom is in the data set, but I do not see boredom here. So these are testing to see, do we have a difference between this emotion and boredom? So I see here, enjoyment and boredom are not statistically significant. So we conclude that they have the same likelihood of being selected. That doesn't mean they're equal. It means they have the same likelihood of being selected. And then I also have my interaction terms. And so we can see that there's definitely a difference between pride and anxiety among the sexes. And here, people are not undecided very often on this data set, which is not surprising because a lot of people have strong emotions about math. I get a lot of hate. All right, so let's go ahead and get the worth off of the model, and then go ahead and plot it. So remember, boredom was our reference level. Boredom is here, and now it's down here. So if I was doing lambdas, it would be shifted up like this. So, or maybe like that, boredom, and then boredom's in the middle. But since it's been converted over, boredom is in different spots. And so we can see very different like range of values. And we can see that pride and boredom are very far apart on the female scale. And let's see, there's anxiety is way down and pride is up here. We can see anxiety is a lot more prominent in the female data. The anxiety, enjoyment, and boredom are all like switched around in their order. Yeah, it's like anxiety and boredom flipped about enjoyment. All right, so now let's take a look at pattern model for rankings. Okay, so here, once again, when we do this, we are going to have a baseline level. Full rankings mean that the subject had to rank every single option. Partial ranking means that subjects didn't have to. They could skip a few if they wanted. So if there were five items to be ranked, they could just put one at 3, another at 5, and they're done. That would be a partial. They didn't have to do all of them. All right, so we're going to use the car configurator data set. And so here, this is just looking at like how important are individual aspects of cars for consumers. And so here we're just saying each of these get ranked from I think 1 to 5, 1, 2, 3, 4, 5, maybe 6 on how important they are. And then we have covariates at the far right of the data set. And so here we have the subjects ranking. So for this, price is the most important. One is highest preference. So interior was the most important for this subject. Then after that was exterior. Then 3 was price. 4 was country. 5 was brand. 6 was technology. And we can see, if I look down here, not all of them are ranked, which means I know that this data is a partial ranking. Now, I also have an age covariate included in here. Now, I can fit the model with the pat bar fit. I've got 6 items because my ranking is 1 to 6. Here's my reduced data set. Remember, I removed a bunch of columns, so I recalled it M. And here's my formula of just depending on age. And so, which covariate are we missing? So we have countries in there. Interior. It took out interior. All right, so interior is our reference level. And so all of these estimates are asking, is there a substantial difference between how likely something is to be ranked compared to interior? So interior is our baseline always. So the estimate is looking at the difference between interior and the item being selected. And then here we have our age levels. 1, 2, and 3. So age 1 is our reference level. Okay, so now I can get the worth of each, and I can look at them by age because that's what my model is doing. So we can see country is the least important of all of them. And then price is surprisingly low. But a lot of people want the exterior to be important, and a lot of them want but we see that older people want the tech and equipment to be more important. That is rather interesting. All right, well, that's all I've got for you. Take care and goodbye.